Ladies and gentlemen, today I am finally going to share it with you how I became a billionaire by using an AI to predict real estate price.
Don't lie, you poor piece of...
Hello, I am a computer engineering undergraduate student and I started learning machine learning a year ago. Before this, I had a pretty good knowledge and experience in languages like C, C++ and Python. So I bought a book, this one to be exact, and I started reading it. I was learning the theory and doing the projects at the same time. And the first project that I did was this. AI predicts real estate price. And after a few months of learning machine learning, I was stunned by just how important the concepts I learned by doing the first projects were. So gentlemen, let's get started. Step 1. Get the data. Our first task is to extract the data into our program. I learned that writing code for simply extracting the dataset is not enough. We have to write functions that can fetch the code dynamically from the source. This way our system will work flawlessly even if the dataset gets updated. So with that said, I am simply extracting the dataset for now because now let's see what the dataset looks like using pandas data frame. Looks like we have 10 columns in the dataset. Our label or target attribute, or simply the attribute we are predicting, is the median house value attribute. The remaining attributes are input to the machine learning algorithm for the prediction. Among those, median income is said to be the most important attribute for housing price prediction. Step 2. Create a test set. Since we want to prevent our model from learning the whole dataset, we create test set and train set. Now the most difficult thing to remember is that the test set is used for testing the machine learning algorithm and the train sets are used for training the machine learning algorithm. Remember that, it's very hard to remember. This is all to prevent something called data snooping bias. So the first method for doing so is splitting the test and train set using array splitting mechanisms and random number generation. But this has a severe fault. This method will generate different test and train set for each execution. So that's why we have method 2. For this, we select a random generator seed to generate the same random number each time the program is executed. But then again, this will fail to work when we will take a new dataset or just update the dataset. So now, for the solution of this, we have method 3. Method 3 is for the smart people. We have to take hash values of each row of the dataset and use that to make the desired set of test and train split ratio. But for the more smart people, we have the easier method, which is method 4. We just import train test split from sklearn.model selection and just use it. Again, some attributes are more important in the prediction model. So we need to divide the test and train set so that those attributes get divided uniformly among test and train set. So for this, we just import stratified shuffle split from sklearn.model selection. And we use it to get the test set and the train set. Now the third step is data visualization. Using .info method, we can get the surface level information about the data set. We can observe that all the attributes are integer data type except for ocean proximity, which is an object data type. But in our case, the object is nothing but text since we extracted the whole thing from just a .csv file. Also, the total bedroom attribute has a few null values, so we'll have to address it later. Is it okay?
Yes, it is okay, bro.
When we take a closer look, ocean proximity looks like a categorical attribute. Now we can see all the categories using value counts method. Oh, do you want to see some pictures? Worry not, because we have matplotlib. Using matplotlib, we can make histograms for all the attribute for us to see. Is that all? No, we can even plot the latitude and longitude against one another to get the map of the area, which in this case is California. Oh my god, that's amazing! And we can also see how much the house value depends upon the attributes using correlation coefficients. And the attribute with the highest correlation coefficient is the median income attribute, as I previously said. Now the second last step is step 4. Preparing the data for machine learning algorithm. Firstly, we have to perform cleansing. Himalaya refreshing cleansing milk is my #1 choice for this. For data cleansing, we first separate numerical and non-numerical attributes. Since we have missing values in a numerical attribute, we will write code to replace its empty spaces with the median value of that attribute. It is recommended to do the same for each attribute even if no values are currently missing. This is because when the dataset gets updated, then there are chances that some empty values will be present in the new dataset. Now, for the categorical attribute, since most of the machine learning algorithm prefer to work with numbers, let's convert the attribute ocean proximity into numeric value. One way to do that is to just change the category name into numbers by using the ordinal encoder. In ordinal encoders, we first change the first attribute to 0 and the second attribute to 1 and so on. But now the machine learning algorithm might assume that the categorical values like 1 and 2 are more similar than the values like 1 and 4, which is clearly not the case. So we have to convert the text into the numbers by using something called one-hot encoder. So it's like putting all the categories into a column, and for a training example, if the category is itself, the value will be 1, and if it is some other category, its value will be 0. I don't know if what I just said made any sense, but look at the example. In the first row, the category is red. So in the matrix containing all the categories, the value of color red is 1, and for all the others, the value is 0. And similarly for the second row, color is blue, so its value is 1 in the matrix, and for the other colors it is 0. Similarly for the third color, the color is. The other part of the data preparation is feature scaling. If data has different scales, algorithm will not work well. So we have to use normalization, which is basically shifting and rescaling data so that their values get between 0 and 1. So the smart people can do this by subtracting value by its minimum and dividing it by the difference of its maximum and minimum value, like so. And the cool people can do it by using min-max scaler provided by scikit-learn, like so. Step 5. Select and train a model. Finally! So the first model that we're going to try is a linear regression model. Linear regression attempts to model the relationship between variables by fitting a linear equation to the observed data. But will a straight line be able to describe the relationship between our attributes and housing price? Seems like not. The model is underfitting. So the model is not powerful enough. So let's use a very strong model. And I exactly know what you're thinking right now. Will this model be stronger than me? No, I'm stronger, but our new model, decision tree regressor, is also pretty strong. So let's train a decision tree regressor. Again, this is a powerful model which is capable of finding complex non-linear relationships. So when we run the code, we get an error of 0, which means the model is perfect, right? Wrong. It is much more likely a case of overfitting of data. But why would you believe me? You are sitting proud believing that you have built the perfect model in the world with 0 error. So to prove that the model is overfitting, I will test the model on our dataset. But should I be using the test set when I'm not so proud of my model yet? No, I should not. So I will be using something called cross validation, which is basically dividing the train set further into a new train set and a validation set. And we train the data on the new train set and test it on the validation set. Scikit-learn provides k-fold cross validation feature, which automatically divides the training data set into 10 subsets called folds. Now it trains the 9 folds and tests on the remaining 1 fold. Now for the next execution, it interchanges the folds. So it runs total of 10 times and returns an array of 10 values as a result. We can take the average of these values to get a real score. In our case, the score is pretty bad, even worse than the linear regression model score. So we'll have to use a model that's a bit less powerful. So let's try random forest regressor. Now the result is very promising, but we can do a lot of hyperparameter tuning. So the only method we have is to test all the hyperparameter values of random forest regressor until we find the best one, right? Wrong again. We just import grid search CV from scikit-learn and use the best estimator, like so. And now our estimator gets recommended to us and we'll simply be using that estimator. And now we can train the whole train set using the recommended estimator and test it in the test set. And the final error we get is this, which is pretty good for an AI.
Like and subscribe. I am desperate. You can remove it later if you regret.